Hello, everyone. Good afternoon. On the behalf of McKinsey Electronics, I'd like to warmly welcome you to today's webinar in collaboration with BPM Microsystems. We're pleased to have over 40 attendees joining us from across the UAE, Saudi Arabia, Tunisia, Morocco, Egypt, South Africa, Turkey, and Pakistan. Thank you all for being here. Allow me to briefly introduce myself. My name is Jad Hakim, and I serve as a strategic account manager for the Gulf region at McKinsey Electronics. With over a decade at the company, I've had the privilege of witnessing and contributing to the growth of the semiconductor industry in the UAE and Saudi Arabia, while also supporting our engineering initiatives across the broader Middle East and Africa regions. For those who may be new to McKinsey Electronics, we are an authorized distributor of electronic components and test and measurement equipment, serving the Middle East, Africa, and Turkey regions. We proudly represent leading global manufacturers such as Samtec, Littelfuse, Osram, ST Microelectronics, and of course, BPM Microsystems. Today's session is an opportunity to see how BPM Microsystems' advanced device programming solutions can support your development and production needs. Thank you once again for joining us. I hope you find this session insightful. And with that, I'll hand it over to Shank and BPM Microsystems team. Shank, the floor is for you.
Thank you, Jad. I appreciate that. Thank you for everybody for joining this meeting here in the middle of your work week. We do, appreciate your time and hope to give you guys some information that's useful and hopefully can find you guys a solution for your programming needs. So with that, I'm going to kind of get started. The agenda for today, we're going to do, brief introductions here on the BPM side. Go through some benefits of offline programming, and then go over our case study, and then show you our solution offerings and go over the APS demo. And then we'll all, open it up for question and answer at the end. On our side, I do have Robert Chenery, Charlie Walton, and Colin Harper from our BPM team available. Robert is our customer care manager. He's our go-to for any tech questions. And Charlie Walton is one of our, head field service techs here at BPM Microsystems. And lastly, I do have Colin Harper, who will be speaking to you guys today. He is our product manager and marketing manager. So looking forward to a beneficial webinar today. Just a brief overview of BPM. We were founded in 1985. We could proudly say we have 40 years in business. Made in the USA, CSA certified, offer the CE mark as well. Our manufacturing and production is here in Houston, here in the United States. And we have presence in over 50 countries and now in the African, UAE, and Tunisia and Turkey markets, thanks to our collaboration with McKinsey. Here are some of our customers. BPM does business in a wide variety of spaces: automotive, aerospace, medical, industrial, IoT, and consumer electronics. We work with semiconductor manufacturers, EMS and programming centers, industrial controls, automotive manufacturers, and OEMs as well. As you can see, these are some of the customers that we've been proud to capture here in our 40 years of business. Some of these are obviously recognizable, and some, are smaller companies. So we really don't turn down business here, and we work with any budget and any small company, large company, doesn't matter. We offer a solution for everybody. With that, I'll kind of go into when to switch to offline programming and problems with outsourced programming. Colin, feel free to, jump in and help me out here if you see anything that I've missed. So when to switch to offline programming, if OBP slows down production, if ICT and FCT fixture costs are too high, if the time to market is too slow, if the customer has a few in-house experts, if your scrap rates are increasing, and if programming large memory devices takes too long. The offline solution is very efficient because you're allowed to, I mean, you're able to program these chips before they hit the SMT line, thus preventing the bottleneck from having to, scrap parts or reprogram devices. So it really provides a benefit that way. Security concerns require if your security concerns require pre-program encryption keys, that's also a great time to switch to offline programming, as you have more control over the security of all your devices, as everything is in-house. Colin, do you have anything to add there?
Well, we found a number of things over the years. These are common problems that we're adept at solving, and certainly having served hundreds of customers globally, thousands of customers, frankly, we find these are common things, and would love to explore the challenges that the visitors today have, and see if we have a solution. So, yeah, this is a good outline of solutions specifically for onboard programming. I think you're going to talk about outsourcing as well.
Yeah, so some of the problems with outsourced programming, definitely a longer time to market, as you have to, ship these parts, wait for them to get programmed to get them shipped back. Whereas with a offline programming solution in-house, this longer time to market is eliminated. There's lower inventory turns. You must have more raw parts and WIP in process. Security and IP protection risks. When you're sending these parts out, you don't have full control over the entire process. Whereas with the offline programming, everything again is in-house, and you're able to keep everything secure. It's also a higher cost per unit when you're outsourced programming. Rework challenges when programming changes. Failed devices must be shipped back for correction, which again, is longer time to market. Design revisions cause rework, adding cost and time. Whereas with the offline solution, any revisions can be done in-house and applied directly to the software. And then scrap when parts are OTP is also a big problem with outsourced programming.
This is a great example of a customer who is facing many of the problems that we've described. Their current or their previous programming process included a combination of outsourcing and custom fixturing and onboard programming, and they realized that they really had an inefficient process. So they came to us. They were in expansion mode. This particular company, well, it's a company called Daktronics, and they make displays. You'll find at football stadiums, baseball stadiums, and things like that around the world. So they're definitely a global player in the display business. And so they came to us and they described the problem that they had. And after some study, the process looks like this. We get a list of their devices that they're programming and outsourcing, and it was a very transparent process, which is helpful for all concerned. They shared with us what they believed it was costing them per device to program, and so it was a challenge we accepted to try to find a solution that would reduce their programming cost per device. And of course, they were engaged with other suppliers similar to BPM. They were looking at another North American supplier, and they were looking at a couple of Asian suppliers. And for them, of course, not only were they trying to find a solution that would program reliably, but they needed a support network that was going to provide the local service and support that they needed, just like they have for the rest of their manufacturing equipment. And so we proposed a Model 3928. It's our 9th generation automated programming site. The particular programming center that they envisioned was in one factory. They actually had multiple factories. And the idea, the vision they had was to support multiple factories eventually with offline programming. And the original ROI analysis looked good. We shared, of course, the programming times and the capacity analysis, what a single machine would be able to provide to their operation, and it all looked good. So they decided to invest in the BPM 3928. Interestingly enough, they were able to support their initial capacity with only 2 programming sites. We'll talk about the configurability of the BPM 3000 series machine in a few moments with Charlie Walton, but suffice to say, they were able to configure the machine and get it at a price point that was capital, not too capital rich. They were able to justify that. And within 6 months of installation, they were able to see a return on that investment. They recouped their entire return on investment. And we were very fortunate that the process, of course, went well. They were fortunate. And so much so that within about 18 months, they decided to take delivery of a second machine. They decided to have redundancy in the factory location was more important than adding additional programming sites. And that allowed them the flexibility, of course, to expand the support to other factory locations. So in Q1 of this year, I believe Charlie did the installation for their second 3928 here in the USA. And so it's just a kind of good example, and we've done this many times over the years where it starts with a conversation. If you're having some pain related to programming your semiconductor devices, then yeah, of course, the McKinsey team and BPM will work together and see if we can provide a solution that will solve the pain that you're having. And of course, we expect this company, Daktronics, they have the potential to purchase another machine in the future with their third factory location. So it was certainly a great win for them, and very fortunate, very pleased that we were able to provide that new value to Daktronics, and look forward to many years of savings for them.
Thank you for that, Colin. Okay, so with that, we're kind of gonna shift to our products here. Robert's gonna go over our manual programmers, and then we will go ahead and demo the APS with Colin and Charlie. So the programmers we're gonna go over today is our 7th gen legacy programmer, our BPM 1710. Also our 9th generation manual programmer, the 2900L, as well as the BPM 210, which is our semi-automated universal manual programmer. And then we're gonna be, and then we will demo our BPM 310, which is our high-level production programmer. So with that, I'm gonna turn it over to Robert.
All right, so here is our line of manual programmers. I'll start with our legacy programmer, the 1710. So the 1710, as stated, is our legacy programmer. It has a 3-rail connector that will accept both single socket module adapters as well as our gang socket module that can support up to 4 sockets at one time. One nice thing about this as well is if the socket wears, you have to purchase the whole module. When the socket wears here, you can simply purchase a replacement daughter card. So the 1710 is our engineering model. So you can, of course, you can only have one programmer per computer. So moving over, with the 1710, though, I should note, we do also have a 2710. Moving over, we have the 2900. This is our universal programmer. So not only does this support most of the 1710 devices, and you can utilize the daughter cards from it for programming, it also supports our vector engine socket cards. The 2900 also supports the Actel line of devices, NAND eMMC devices with speeds up to HS400 for programming. The 2900 is a small production model, so you can connect up to 12 programmers per computer. The 2900 we also support is a 2900L, which includes a lever to allow for easier opening and closing of the sockets. So while this was nice and the manual was great, we still had room for additional. So we released the first ever semi-automatic programmer, the BPM 210. The BPM 210 has not only a pressure plate to allow for automated opening and closing of the sockets, it also is able to support the vector engine socket cards from the 2900, as well as our new two-socket socket cards that can program up to 8 devices at one time. You simply put your socket cards onto the programming site, install the pressure plate, close the lid, and you can begin programming. The 210 also, of course, has safety features to prevent any injury during programming for your operators, with an interlock on the lid that requires it to be closed at all times, as well as an emergency stop button if needed. The 210, just like the 2900, can program up to have 12 sites connected to one computer. And it also has the ability to support UFS devices. The 2900 also supports up to over 40,000 devices right now. The 210, while not as many, is growing every day. Finally, just to kind of show you a preview of our automated sites, this here is one of our automated sites and its individual chassis. What's nice about this is not only do you have the ability, it has modularity within the machine. This chassis can support both the automated 210, 2900, and even the 7th generation auto site. It's giving you complete control of your automated system in how you would like it configured. So are there any questions in regards to manual programmers?
So the question is, and it's coming from Karen, she is asking, why does the 210 model support less devices than the 2900?
I'm sorry, ask again, please. By what?
Why does the newer version of the semi-automatic programmer supports less devices than the legacy 2900 model?
Well, I can answer that question. So, yeah, we made the decision because the architecture of the 10th generation BPM 210 is slightly different than the 2900, that we would ask customers to enter their device requests, and we would qualify those devices as needed. As Robert had said earlier, we can support the FVE, the vector engine socket cards that we've developed for 9th generation. But, our goal is to deliver Six Sigma quality. And so it's incumbent upon us, for manufacturing companies around the world, that we do qualify that support. And of course, we have a large team of device support engineers that are based in the US and in India, and we're well equipped to respond quickly to those requests and qualify the new support on the BPM 210 as needed. Okay, good afternoon again, everyone. And we're going to continue with the presentation this morning. And I'm Colin Harper. I'm the Director of Product Management here. And we certainly appreciate everyone joining today, and look forward to telling you a little bit about the BPM 310 and the technology we have built in. This is Charlie Walton, our Senior Field Service Engineer. And Charlie, you've been all over the world installing automated machines. Tell us about some of the places you've been recently.
Oh, well, let's see. I've installed a machine in Poland, and one in Hungary, and of course in Germany, and all over the US as well. And yeah,
So you have a lot of flight miles, I suppose.
I do.
Yeah, well, great. Well, let's jump right into the BPM 310. This is our flagship automated programming system. It includes, actually, this machine is configured as a hybrid machine, which means we have a combination of the 9th and 10th generation programming technology built in. As the visitor asked earlier about device support, of course, we're a hardware company, but frankly, every day we're supporting new devices on our platforms. And the advantage of the 9th generation in this configuration is that it supports over 40,000 devices right out of the box, as we like to say. And then the 10th generation technology, you'll see in a moment, includes, of course, the added socket capacity. So for a customer who's programming high density flash, something or UFS perhaps, the 10th generation is ideal. It is universal, but again, the support count right out of the box is somewhat lower. So kind of as an overview of this machine, I mentioned earlier that our machines are highly configurable. Today we have a demo, including the TS1500 trace stacker. This particular trace stacker can support up to 25 thin JDEC trays for both input and output. We have a tape feeder input bay, and we support a variety of tape feeders ranging from 8 millimeters up to 56 millimeters. And to complement the tape input, of course, we have a tape output. This is a VTech TM50 MK2. This is an OEM version of a VTech tape loader that we have requested some specific features that did not exist at the time. And again, this machine capable of both heat and pressure sealing on the tape output side. You can also integrate a inkjet marker on this TM50. We don't have that today. Some of the other options that we have installed, we won't demo. We have a fiber laser marker, 30 watt fiber laser marker. So you have the ultimate traceability per device. You can do things like date code and serial numbers, and you can even track which socket and which programming site each device was programmed on for that ultimate traceability. I guess the other options we don't have included, this machine does support tube input and tube output. We don't see as much of that today, as you can imagine. That's mostly legacy devices. But if you're manufacturing for aerospace and military defense applications, certainly there is that possibility that you might still need tube input and output. And then last but not least, well, actually two more things. We do have the ability to install a label feeder here on the machine in this area that I'm pointing to, so that if you would prefer to have traceability per device with a label, you can do that. And then for the ultimate in inspection technology, we have a 3D inspection module that can be installed in the machine. As a whole, the machine, again, is highly configurable. We have a universal platform. This particular technology between 9th and 10th generation can program basically anything in the industry today. And then the handler technology is fully universal. So we can support anything from the smallest CSP device down to 1 millimeter by 0.5 millimeter in X and Y, up to a very large, say, QFP of about 33 by 33 millimeters. So very capable system. And the goal is to install a machine like this, and you can have the confidence that you can program anything in the market in the future and today. So Charlie, let's talk a little bit about the architecture, maybe inside the machine, single nozzle, downward vision. Tell us how all of that works together for a customer.
Sure. So, of course, the nozzle, and we supply a nozzle kit with the machine of about 6 or 7 individual nozzles. And a nozzle is a part of a job changeover. You need to have the correct nozzle size for the device. Along with that, a job changeover would include all of the sockets And again, these sockets are the same ones that would be used on the manual box desktop units.
Yeah,
And-
perhaps, why don't you,
and
why
they have
don't
a
you show
pressure
how
plate.
this works?
And move the socket. And this is all part of a job changeover, and a job changeover is completely toolless. It's all by hand, no tools required.
So Charlie, you and I have done a number of videos over the years, and if the customers would like to go to the BPM Microsystems YouTube channel, BPM Microsystems, look for that. And then there's a number of videos out there where we show a changeover. You know, we claim, 3 to 10 minutes, depending on the complexity of the job. And I think,
That's right.
we've proven that many times over the years that a competent operator can change over between 3 and 5 minutes.
Correct. So you can configure the job multiple ways, and we call that a workflow. And I will give you a screen demonstration here shortly. But the idea is that you're going to take devices from a source or an input, and you're going to program them. And then you're going to output your past devices, whether it be tape or tray or tube. And you may also be marking the device with either a laser mark, a label, or ink dot.
Let's show them where the laser marker is
Okay.
inside the machine.
Yeah, this is the laser marker here. It's got 2 nozzles that will flip around. And of course, the laser itself is down inside the machine.
One thing that comes up pretty often is, dust. Tell us about the dust collection system to keep that out of the
Sure.
out of the factory environment.
Sure.
Laser-
So yeah, laser marking, of course, is going to be burning the surface of the device, which creates dust. And of course, we have a robust dust collection system inside the machine, a HEPA filter, and also a carbon charcoal filter. And those need to be serviced on a regular basis. And that's part of the machine maintenance.
And there's a shutter, of course, that we
A
can't
safety
operate,
shutter,
safety
that's right.
shutter. So everything is enclosed. It's a class 1 laser, again, 30-watt fiber laser, and very capable system. We can mark devices down to about 0.3 millimeters. May not be human readable at that character height, but again, very capable. And you can adjust the power and speed so that you simply etch the very top surface of the device for traceability. So we have, moving on, maybe is the alignment system. Let's talk about our capability that we have for very small package alignment. And
Right.
this on-the-fly vision alignment.
Right. So we use a cyber optics camera system that it works what we call on-the-fly vision centering, which means that every time we pick up a device, we're going to raise it up in the camera's field of view and rotate the device. And this is done at high speed, of course. And the camera will run an algorithm to determine exactly where the center of the device is in relation to the center of the nozzle, so that when we go to place, it may need to apply an XY correction to place accurately. And this is for every device, for every placement.
One thing customers ask us, why not multiple nozzles? And of course, back to our mantra, we want to make device programming easy by having a single nozzle with an on-the-fly vision alignment. It's a very fault-tolerant system. You don't have to have a perfect nozzle run out, if you will, and the device can still be centered properly. Again, gives us that capability of fast setup and changeover, and very little calibration required. In fact, Charlie, when the machine initializes, my understanding is it does go through the calibration process to make sure that everything is set
Yes,
properly.
yes, it does. The initialization of the machine basically checks the hardware, and if the initialization will pass, then the hardware is in good enough condition to run a job. What I'd like to do now is let's do a short job tray to tray, and I'll demonstrate the tray stacker
Okay.
inserting the tray into
Sounds
the
great.
machine. Comes the tray, gets clamped down into position. I'm going to change my screen here to share. Am I sharing now?
Right, sure.
Here we go.
Guys, just a heads up for the attendees that there are two screens shared.
Says I am screen
So
sharing.
you can see Robert's screen on the machine, and
There it is.
there's another screen
Okay.
shared for the
No,
software.
We're good.
We're good? Okay. So here in BP Win, auto handler, I'll show you what the workflow looks like. If you see here, this is a source, and we're going to, well, I'm going to change this to run from tray to tray. This is actually set for tape in and tape out. So let me go ahead and just load the job here. We have one here called tray to tray. This is a work setup verification screen. Back to auto handler workflow configure, you can see that we're going to be the source are devices on the the tray, and then programming sites. We're going to program the devices. We don't have any markers. That would be, for example, laser or label or ink dot. And then past devices are going to go back to the same tray. And then if there's any rejects, they're going to go to a redirect location. We'll say okay. At this point, I can set a job quantity. We'll just, for brevity's sake, we'll just do 10 devices real quick. And I'll hit program. And then we can watch the machine in action. As you saw previously, we have a tray. It's a partially filled tray, just for our demonstration purposes. And it's been presented in the tray stacker. Okay, and so the handler's going to do a quick initialization and open the sockets, and then take the first device. There we go, socket 1 opening, socket 2 opening. Take the device, put it in the first socket. Yeah, we'll move that camera over. And finish that one. So it's populating site 2 now, 8 sockets. And our 10th and last device is going to go back to socket 1. And after programming, the devices are going back into the tray. At that point, we're going to receive a job summary report on screen.
So Robert, let's take a look at the some of the contents in the job summary. This would be a good time to mention the factory MES, or the API that we can connect to the BP Win application. Our application is called BP Win, and of course, having intelligence to make device programming easy and learning as you go is really important to our customers. And so we have recently released a very easy to use a new REST API application for BP Win software, and it's the ultimate in traceability. You can do things like monitor the machine in real time, and then you can also set up jobs and control that. So taking the operator variability out of the process to again, that goal is Six Sigma quality or better, so you can do job control as well. And the cool thing about the BP Win application with REST API is that it's very, very, again, easy to use. We have a toolkit that's posted online that can be used, can be accessible, and just a lot of power built into the API. So it gives you cues to what you can do to improve the process as you adopt offline programming. Maybe any questions thus far? No? Okay. So Charlie, we have another job set up and that's tape in, tape out. But before we actually run that, let's talk a little bit about the TM50. Give me just a brief overview of the TM50, how it plays with BPM software, and how it integrates with job saving.
Sure. So the TM50, the tape output station is completely universal. It'll handle any size of carrier tape and cover tape. It's also universal in that it can do both heat seal and pressure seal. There's actually six sensors on the machine to detect if there's any problems. It will pause the job, throw a message, and of course a warning light, and then the operator can take care of any problems. Also, the setup of the job for the tape, which would include things like the pitch, the speed, the dwell time for heat sealing, all of these parameters can be saved as a job in the controller unit itself, but tied to BPWin so that when the operator selects a job, it'll automatically send the parameters to that tape loader, and it'll set the job up. So kind of one-stop shopping there.
So Charlie, to kind of summarize, for a typical customer on the machine side, we have our BPWin software that communicates with the TM50.
Correct.
We have what's called Job Master. We didn't introduce earlier, but we have job files that we can create and save. They don't have to be done at the BP level. They can be done offline. The automated side, of course, has to be configured at the machine, but those can be saved. And for your typical manufacturing company that runs the same jobs repeatedly over the course of a month or a year, once they qualify that job and they set up the TM50 to be saved there, they know that it's going to behave the same way each time. Is that correct?
That's right. Yes, the actual programming job is a file that can be shared. You can email it to anywhere in the world. It can be password protected to make sure that nothing gets changed. Right. And of course, teaching the machine is quite simple. I can demonstrate a quick teach, and then we can run a tape-to-tape job so you can see that in action.
Let's do that. In fact, just for context, Whisper Teach was one of the patented inventions that the BPM had a few years ago.
Yes, it is.
And we recognize the problem of running chip scale package parts I described down to 1 millimeter by 0.5 millimeter, those type of tiny parts, about the size of an 0402 component.
That's right.
And we realized that the human trying to detect the teaching was very difficult. So thus we invented Whisper Teach. So tell us about Whisper Teach and what that does to the teaching process.
Okay. So Whisper Teach, of course, we developed this to solve a problem. The problem being dealing with really small, lightweight devices, especially when doing an auto Z teach, where the machine is going to automatically learn the Z coordinate of the teach. And what traditionally has been done in the past is that, you click the button to teach, and the nozzle is at the top with the vacuum on, and it comes down looking for a device, and at some point it gets close enough where the device jumps up onto the nozzle because of the vacuum. And if the device is really small, we've seen them fly out of the pocket or the socket, flip upside down, even landing on the edge of the nozzle. But a lot of problems trying to auto learn the Z coordinate with very small devices. So what Whisper Teach does, instead of turning on vacuum, we're actually going to turn on a very low flow of low pressure, and the flow is controlled by a needle valve. And so as the nozzle is going down, it's actually blowing out just a very little bit gentle flow of air. And we're looking for a very tiny change in voltage from the vacuum transducer, so that as the nozzle actually touches the surface of the device, it's going to block that flow of air, and that's a small voltage that's detected. And we use that to determine where the surface of the device is, instead of vacuum with the device sucking up onto the nozzle. And so that is Whisper Teach. And it works very well, I might say.
And we have a video again on the BPM YouTube channel that describes the Whisper Teach challenge and shows it in action, a close up.
In slow motion even.
Right.
It's
so
impressive.
we can achieve 15 micron accuracy.
accuracy,
with
right,
whisper
in our
teeth.
Z coordinate because of whisper teeth.
And, you know, machines these days, all machines, they're very accurate and repeatable, but they're only going to be as productive and get the yield you want if they're taught properly. And the nice thing about the whisper teach process, it really does take the operator skill out of the process. And we like to say it's so easy, even a sales guy can do it. So no offense to the sales team, but you know, that's the reality. We ship these machines to trade shows around the world, and the sales team often does the installation and setup, and it is really that easy.
It really is.
Okay, so you were going to demonstrate quickly the teach process.
Yes, sure. If you want to come over to this window here, my shared screen. So I've already loaded our tape to tape job. I'm going to go ahead.
1 second, Charlie.
Okay.
Robert, please. There it is.
All right, I'm going to go ahead and teach the tape in. And we just select it. And notice that this the menu here, this is everything in the workflow. And so we're just going to and of course, once you set the workflow, you have to teach everything in the workflow before the job will run. And the software won't even let the job run unless everything has been taught. So just some pin 1 selection here. And make sure there's a device, and there is.
And Charlie, just to clarify, you're teaching the tape.
I'm teaching the tape input.
So we didn't talk about the downward vision camera. We do have a downward vision camera in the machine, and that's used purely as a kind of XY coordinate teach.
That's right.
Charlie, is that correct?
That's right, yes.
Okay.
So I'm going to teach this a little off center, but the cyber optic camera is going to correct for that. So whisper teach is going to happen now.
So just to reiterate what you said, the whisper teach will compensate for the Z height, but the cyber optics is fault tolerant in that the operator doesn't have to perfectly place
That's
the
right.
coordinate of the center of the device.
That's right.
So that's a simple teach.
That's right. And it's that easy. And when the teach is completed, if it finishes successfully, then know that the teach is 100% perfect and it's automatically saved.
So when we say to set up a job within, say, less than 10 minutes, let's say, for example, a typical 3928 with 8 to 12 sockets, you know, could be more. Each process, each step would be that easy. You
Yes.
teach it exactly the same way.
Right.
And you would teach your inputs and your outputs the exact same way as well.
That's correct.
So it'd be easy to see how we could achieve in less than
Right.
10 minutes.
Okay. So we're going to do another 10-piece job, taking from the tape feeder, programming, and then output to the tape loader.
Hold on. Okay. Right. We're seeing the right camera. Go ahead.
Okay.
So we've already placed the first device in socket A site 1. And the machine is intelligent enough to optimize the throughput. In other words, it'll pick the programming site closest to the workflow
That's correct.
so that you can get the maximum DPH. And I don't know that we mentioned earlier, of course, this machine can do up to 1,432 devices per hour in trade and tray. And, that equates to millions of devices per year. Many of our customers run this system 3 shifts, 4 shifts, 24/7, and can program millions of devices per year on this relatively small platform.
That is correct. Okay, well, that completes that job. Let's talk a little bit about the maintenance of the machine.
Okay. You're the expert, Charlie. Please proceed. What do we need to know about maintaining?
Okay, so maintaining the machine is really quite simple. And of course, whenever a machine is installed, we give a training class with a recommended maintenance schedule and of course, step-by-step procedures. A lot of these are available online on our videos. But basically, you're going to keep the gold scales, encoder scales clean, keep an eye on the filters and replace those when necessary. And of course, you have the laser, you have the HEPA filters inside the machine that you also need to service.
And Charlie, the machine ships with a spare parts kit.
It does, and a lot of these filters are included in that kit.
So that's what you would expect to consume during the first year
Correct.
of the warranty period.
Correct.
And then if you want to renew the subscription, the warranty subscription, you could do that. And then what's the typical process for maintenance? How many times per year and that type of thing? For example, you're on the road a lot. What's your role?
Right. So the users themselves, maybe they have a maintenance team or whoever is in charge of the machine. It's probably about 5 minutes a week just to go through a series of checks and cleans. And then we have a recommended monthly, takes about 5 to 10 minutes, and then annually. And of course, we will come out once a year, as long as, certainly within the first year. But if you have a service contract, we'll come out and annually we'll do a thorough machine inspection, cleaning, replacement of anything, and as well as a COC calibration on the programming sites themselves. The handler itself is self-calibrating, and the programming sites are also self-calibrating, but we need to check that calibration. And if it passes, great, we'll give a sticker. It's good for a year. Otherwise, the programming site would have to be sent back to Houston for repair.
So speaking of stickers, of course, safety is very important. And we've operated the machine today kind of in an unusual state just for visual purposes. The machine is CE mark certified. So you know that the machine directives and all of those important things relative to operator factory safety are built into the system. So for example, we have an interlock system built in, and we take safety seriously. Let's pivot for a moment and talk about installation. Again, you've been all over the world, installed these machines. Describe to the audience what an installation looks like, how long it should take, and what it includes.
Sure. So, of course, the machine would get shipped to the facility, and at the point when the machine is on site, we'll make the travel arrangements. The first day will be uncrating the machine, getting it set up and tested. And of course, there's a series of diagnostic tests in BP Win that you test the hardware. And this is all part of training as well, which at the end of the first day, you should expect to be supplying chips and sockets, and we can set up and run the first job. Then the following day would be a continuation of training, getting all the operators training. We have a training class for operators. We have a training class for the technicians on what to do for any troubleshooting, on-site repairs. And then, of course, the maintenance training class going all over the steps for the preventative maintenance of the machine.
So
and this can all be done in about 3 days.
3 days.
And by the end of 3 days, you should be full-time programming.
Very good. Well, Robert, maybe we can open it up to questions.
Absolutely. So do we have any questions?
Robert, I have something but probably related more to the service side, and Charlie, certainly installing the machine is really important, and it goes well. You don't leave the factory until your customer is satisfied.
Absolutely.
But
yes.
Any commentary there?
No, we just want to make sure that the installation has gone well, the training has gone to the customer satisfaction. And training is really critical, because the operators, if they don't really understand the machine, they're going to have a lot of problems, and it's just not good for anybody. So we want to make sure we take the time, do really good training, make sure the operators understand and are comfortable with the machine. And again, it's not a complicated machine, and we've done a lot in software to make it as user-friendly as possible. And but that training, of course, is key. And so we're not going to leave the factory until we have your written acceptance that you are happy that the machine's been installed and everybody's been trained to your satisfaction.
And what I was going to comment, Robert, the onboarding process, the installation really starts weeks or even months prior to the machine arriving. Let's face it, you're counting on this production equipment to support your factory. These machines typically support multiple production lines. So what you want to do, of course, is qualify that process ahead of time. So Robert, we didn't plan this, but can you speak a little bit to the onboarding process, what that looks like?
Yes, absolutely. So the onboarding process would starts as pretty much right after the machine order has been accepted. The process goes over timelines for the completion, shipment,
So
installation.
this is a conversation with the customer, correct?
Correct, with the customer.
Right.
We go over the layout, confirm the supports, provide documentation on the machine, and we also even set up or answer any questions you have, as well as questions we have, to make sure that we are completely in line with your needs with this system. We also then, this isn't the only meeting you will have. We'll set up monthly meetings going forward to make sure to provide updates, as well as make sure we're still staying in line. And then, of course, there is the installation and training. And then not long after that, we do a final meeting where we will go over everything and get your feedback, how the experience was, any improvements you'd like to see, so that as you purchase more machines in the future, we continue to excel and improve the process and make it even more streamlined as we move along.
So Robert, device support is typically a very important part, integral with the onboarding process. And typically we will pre-qualify those devices. So I know there's a couple of options. We can send a manual programmer. Let's say they buy a automated machine. We can send either a BPM 210 if it's a 10th gen, or a 2900 to the factory location, and we can work jointly with them to qualify the device support. Because the goal is, when Charlie or whoever does the installation, by the time we depart at the 3 or 5 day mark, you're ready to run production. And so that implies that we've already pre-qualified all of the first articles with that customer. So that's a really important step as well. Feedback from our customers, I mentioned Daktronics earlier, they realized the actual offline programming process was not the challenge. The challenge was changing their process and making sure that everything that they previously programmed, either outsourcing on different solutions or even on board, that they pre-qualified those jobs using the BPM tools as well. And we're going to take you by the hand and make sure that process is smooth and done properly. Charlie, one thing we did not talk about is prepping the factory. So again, part of the onboarding process. Tell us about the air and power. This thing does consume a little bit of air and power.
Right. So we do provide an installation FAQ document, and that lists everything that one should expect for the installation, as well as the requirements for the machine that you would have to supply at the factory. We require 230 to 240 volts AC single phase, and compressed air, minimum of 90 PSI for the machine. And then, of course, if you want to provide a network connection so that you can download any of your programming files from your network, your domain, and and that's pretty much that.
Charlie,
Okay, we've
Robert,
covered a pretty broad, we covered the machine pretty well broadly, and would love to open it up for questions, Robert. I think there are a few questions queued up. What maybe you can tell us, and we can field that, or whoever you think would be appropriate to field the questions.
Absolutely. We do have a couple in the chat, but Jad, I do believe you were about to ask. Okay, the first question I have here is from Jad, actually. What is the expected lifetime of the machine?
Okay, well, I will field that. Our technology in general has a fantastic track record. You know, we believe return on investment is important to everyone. For example, the 7th gen technology that Robert talked about, we do have 7th generation automated programming machines that were installed in the mid 2000s. In fact, prior to that, they might have been 6th generation machines that were upgraded. So, you know, we have a 8-year technology guarantee. Technology does change rapidly. We source components from all over the world, but you know, our commitment is a minimum of 8 years. But in practice, we have machines in operation that are over 20 years old. And because we design, manufacture, and support all of this equipment ourselves, then it's easier for us to make a guarantee versus, say, a manufacturer in Asia or even the USA that are sourcing machines and modules from someone else and trying to guarantee some kind of life. So it's one of the hallmarks of BPM is that we support machines for many, many years. What else, Robert?
The next question is, how does BPM handle rapid onboarding of new silicone devices from different vendors?
Well, so I mentioned earlier, we're a machine manufacturer. We support these machines and technologies, but our staff, if you looked at the engineering team, is mostly device support. And we're supporting multiple software releases per week today. And we have been doing that for years. Our combined support count is over 80,000 devices. So frankly, that's what we're good at doing. Now, lead times can vary depending on complexity and just being quite transparent, workload. You know, we have a team here in Houston, we have a team in India, and they're full-time working and adding new support to, you know, 7th generation, even 8th generation, 9th generation, flash stream, and now 10th generation. So it's impossible to say exactly, but you figure 4 to 12 weeks, depending on the complexity of the new support is what we aim for.
So the next question is, can the system generate automated reports on failed devices, retries, and socket wear?
Robert, I'll let you address that one. It's right up your alley.
Thank you. So I'm going to go ahead and switch this over to the other screen because the job summary report kind of helps outline this. If you can scroll down to the statistics. So every job, of course, has a job summary report where we list out the failures. If you go further down on site statistics, so for here on the site statistics, you see which sites were utilized, how many devices passed or failed, as well as the yield. Now, just since nothing failed this time, but if it does happen, just below, it does list out what failures you see and how many there were of those failures seen. As for socket wear, if you scroll down a little further, Charlie, we have the socket module insertion counters. Here you get the total number of insertions that have been recorded. You can even, once you've reached the max for the socket, which our average is 10,000, you can replace the sockets and reset the insertions for the new socket. You can even set up maintenance intervals. And what's great about all this information is the REST API can pull this for you real time and provide you with the visuals as well as record this into any documentation you need or software.
And then we have the black box log, which is another layer necessarily to show today, but that gives you a lot of information, real-time logging as well.
Absolutely. The black box log file shows step by step every action that the APS pick and place does, as well as if there are any errors, it will report them, as well as provide additional information on exactly what the error was.
And then at a programming site, level diagnostics. We ship a diag card, which with the machine to perform a diagnostics test as well.
Yes, that's correct. We do have a diagnostic card that will test everything up to the socket connections on the programming site, checking all analog digital pins, all timings, all voltages, make sure that everything is within specifications. Anything that deviates will be marked as an error and the diagnostic will fail. You can also even run diagnostics with the socket card so that you can test up to the PCB on the socket cards themselves to confirm if there are any errors or variances that mean that the card will need to be either repaired or replaced.
Do we have any other questions for Colin and Charlie? Looks like we got one come in. Is it possible to stream real-time programming data from your systems to the cloud or a data lake for broader analytics across multiple production lines?
So Colin, do you have for, as stated by in here again, is it possible to streamline real-time programming data from your system to the cloud or a data lake for broader analytics across the multiple production lines? Again, yes, this is where the REST API would be utilized, as it would be able to not only pull this data, but you can then integrate it into your existing systems for storage of that data wherever you need it to be placed.
Okay, guys. Well, if there's no other questions, we do appreciate you for joining. Thank you for taking time out of your day to see what BPM has to offer. Hopefully, we can work together, find a solution for your companies moving forward here with our distributor, McKinsey. And looking forward to speaking to some of y'all personally. So, Jad, I think I've recorded this as well, so we can share these with everybody that's taken place. And of course, if there's any questions, feel free to reach out to Jad or anybody here at the BPM team. We'll be happy to help.
Definitely, Shank. I would like to thank you as well for organizing this webinar and for demonstrating your products and how useful they are in the production lines of our clients. So I would like to thank you all as well, and we'll be in private discussions, of course, with the clients to provide more information on how we can support them.
Okay, sounds good. Thank you guys so much for joining. Thank you, Colin, Charlie, and Robert, for your help. And look forward to speaking to you guys soon.
Thank you.
All right.
Thank you, everyone.
Thank you, guys.
Thank you.
Thank you. Have a good day.